I told
it's
you
bullet.
those are full.
Yeah. Pretty good aim, I guess, because they can spell out letters,
Oh, okay.
but not something we encourage today.
No. Yeah.
But the petroglyph panels too, you can see bullet holes up in them that people.
And what does it mean, like at RGZ?
There will be a geology program just outside the visitor center. So if you're interested in learning a little bit more about the neat rocks you've been seeing around the park, meet the ranger just outside the visitor center in about 5 minutes at 10 o'clock for a 20-minute geology program.
Certainly a lot of geology here.
So we're going to get started in a couple minutes, but just like to take this time to remind you guys, it's pretty hot here. We're looking at 80 degrees today, so just be sure to be drinking a lot of water when you're out here. Try to drink at least 2 liters a day myself, so it's easy to forget, but it's so dry. It's important. We don't want anybody getting dehydrated here. Welcome you all to Capitol Reef National Park, and thanks for coming to my geology talk today. It's going to be about 15 or 20 minutes long. Capitol Reef has been a national monument since 1937. We became a national park in 1971. So part of the reason we're a park is to protect the plants and animals here, to preserve the relics from the Fremont culture that was here in around 1,000 years ago, and also to preserve the settlements and the historic orchards from the Mormon settlers that came through the area. But the main reason we're a park is because of the amazing geology that we have here. Kind of a disclaimer, I'm not a geologist by training. I'm actually from Georgia, which is very, very different from here, and pretty much like we were talking about Scotland, all the geology in Georgia is covered up by vegetation, but here it's kind of right there in your face. When I first came here, it felt a little foreign to me, all these kind of interesting rock formations, strange colors. Anyone else feel like maybe it was a little strange? Like you're on an alien planet or something? So today I'm hoping to give you some information and some tools to kind of understand the geology that we see here and some of the geologic processes. Pretty much everything in the park is shaped by the geology, and it might not seem like it at first glance, but Capitol Reef is a really dynamic place. Has been in a state of change for millions of years and is continuing to change today. So as we were driving in on Highway 24 today, you might have noticed some of the different rock layers that we have here. We have sedimentary rocks, so all of these layers were deposited in different environments, and geologists can kind of read those layers, almost like reading a book, to learn about what the environment and the climate was like here when those rocks were deposited. So I passed out these brochures that show you on the back the stratigraphic chart of the different rock layers that you can see here. The rocks that we're looking at range in age from about 100 million to 275 million years old, which is a huge span of time. And to kind of put that in perspective, can I maybe get a volunteer? It's nothing scary, I promise. Yeah. Anyone? Thank you. I mean, I could do it, but it's better if I have a victim volunteer. So, what's your name?
Debbie.
Debbie is going to be our timeline today. So if you can just hold your arm straight out for me and pretend this is the history of the world. So starting over here is 4.6 billion years ago when the Earth was formed. A lot of stuff is happening in this time frame, but we're going to kind of skip over that. So right about here, this is 1.8 billion years ago. This is when North America was formed. So before this, it was one giant landmass called Pangaea, and at about where her shoulder is in the timeline, that's when North America broke off. So the rocks that we're looking at today, I said 275 to 100 million years old. They start probably about here, the palm of our hand on this timeline, to a little bit, maybe half an inch down our fingers. So you can see in the scope of the geologic time scale, it's not very much that we're seeing right here. Do you guys have an idea where humans might be on this time scale?
Fingernail.
Yeah, it's like the very fingernail. So if I had a nail file, I could just wipe out like all human civilization. Thank you, you don't have to keep holding your arms. I just like that someone did that for me during my first geology training, and I thought that kind of put it in perspective. I mean, we're seeing a lot by looking at the palm of the hand, but just barely the tip of the iceberg here. So yeah, you can look on your charts, which and see the stratigraphy. So we have 16 layers that are visible here in the park. I'm not going to go over all of them today, just some of the coolest ones. So if we all kind of look, some of you might have to move to see this. We have this formation called the castle up here. Kind of see why it's called the castle. It kind of looks like one. So I'm just going to talk a little bit about the rock layers that we can see in there. So along the ground, there's kind of this brown, soft layer. That is called the Moenkopi, and that is about 245 million years old. I'm going to pass around a chunk of rock. That's an example from there. It's also called ripple rock, and as this gets passed around, you'll see you can actually feel the ripples in the rocks. This was deposited when this was an environment that was kind of like a lazy tidal flat system. So I like to think of Cape Cod, you know, with the waters like moving over the sand and causing those nice little ripples. So it's kind of hard to imagine being in Cape Cod here, but that's what it used to be like. And we call that ripple rock, Moenkopi. And one of my favorite things from that, I'll pass these around too. In the Moenkopi is where we find dinosaur swim tracks. So what I'm passing around is there were dinosaurs that would be kind of swimming and walking across the sand, and the impressions from their claws would be left into the sand. And then these are molds that were then the rock that was deposited on top of that. When we pulled that away, they've been preserved. So you can actually see the little marks from their feet.
Which layer are we talking about?
It's the brown one that's kind of even with us on the ground, the soft one, the Moenkopi. But moving on up from that, you kind of see this greenish layer that goes up kind of a talus slope to the sharp cliffs, and that's all part of the Chinle Formation, which is this kind of greenish one that I have here as an example of it. This is from about 225 million years ago, and we get all sorts of kind of fantastic colors in the Chinle Formation, greens and reds and yellows. This was deposited when this was kind of a swampy delta system. So think about maybe the Mississippi Delta area. So there would be periods of time when it would be covered with water and very swampy, but then also it would dry up a little bit and the rock would be exposed. So we get these different colors. It's all kind of based on the iron that's in the rock and how oxidized it is. So basically, when the rock was deposited, if it was deposited underwater, that iron was in a reduced oxidized state. It didn't have a lot of access to oxygen, and it would become that green color. So if it was deposited in an oxidized state, exposed to the air, it's a red color. So kind of like if you think about leaving a bike or a tool outside in the rain or the weather, the iron in that is exposed to oxygen and makes it rust. So kind of like that, that's how we see these red colors are from the rusty iron in the rocks. But the Chinle is my favorite formation because that's also where we find petrified wood. And you can actually see on that piece, there's still some bark that's been preserved there. So petrified wood is formed when a tree dies, 225 million year old tree dies and is somehow protected, maybe it's buried or otherwise protected from decay. So it becomes preserved. The organic material in it becomes rock, it becomes lithified, so we get these fossilized trees essentially. And as those are going around, we can kind of move up, and now we're looking up at the castle of this sharp, fractured rock. That is called Wingate sandstone, and if you look over towards the right as well, you can see kind of the rounded white domes, and that's called Navajo sandstone. So these are both types of sandstone. Deposited here when this was a huge desert environment. We're talking Sahara, really, really big. Geologists believe that some of the dunes were a mile high, and in geologic terms, a big desert like that is called an erg. So I have two examples of this, and maybe if I can get, what do you notice when you're feeling these? What's the difference between them?
Bigger green.
Yeah. So as you're passing these around and you can feel them, the Wingate is really heavy and dense. It's more tightly compacted, and the Navajo is a lot more porous, and you can actually erode it away. You can feel the sand grains as you're rubbing it. But both of these are from desert environments that were here. These rocks that we've got. So as I said, there are about 16 layers here, and those are only 4 of the ones that we can see here, but there are a lot more that you'll see out in the park today. And as these were deposited over 150 million years, they're all deposited in nice horizontal flat layers, kind of like this sponge. Imagine this 2 miles of rock layers instead of a sponge. But looking around us today, we can obviously see that everything's not nice and flat and horizontal. We've got a lot of different elevations. So we had some big change that occurred. So about 70 million years ago, the Pacific Ocean plate was butting up against the North American plate, kind of around where the coast of California is today. And the Pacific plate was subducted underneath the North America one. So basically the oceanic plate was denser than the North America plate and slid underneath it. And this took 20 million years, so this wasn't a quick occurrence. But even though that happened around the coast of California, we felt the effects of it here in Utah today. So along this kind of north-south line in the park for about 80 miles, way down deep in the bedrock underneath all these layers that have been deposited, there are some ancient faults. And when that the subduction happened with the plates, it caused the faults to reactivate, so half of the rock shifted up. So imagine my nice layers like this. When half of the rock shifted up, these rock layers on top folded up as well into what's called a monocline, like this. And our monocline here in the park is called the Waterpocket Fold. You guys might have heard about the Waterpocket Fold or seen it on your map. So it kind of angles like this if I was doing it accurately with the line that we have here in the park. So all those layers are now tilted and now more vulnerable to erosion and can be exposed a little bit easier for us to see the different layers in the monocline. As those layers became more vulnerable to erosion, we've gotten some of the features that we can see now today looking around in the park. So I was talking about the Navajo sandstone up there, and that's kind of where we get half of our name, the capital part of our name, because that Navajo erodes into what look like domes. And one of those domes looks like the Capitol building's dome, so that's where we get the capital part of our name. I'm passing around a picture here so you can kind of see the dome shapes that form. Another thing we get from erosion is what's called water pockets, which is what our water pocket fold is named after. So those are depressions in the rock that have been eroded away from rainwater, and literally are pockets in the rock that are then filled with water and are kind of fascinating sources of life for little microscopic organisms and shrimp. And a lot of animals depend on those sources of water to survive here. So you can see the picture that's passing that around as well. We also have some pretty fantastic slot canyons in the park. Those are also formed from erosion. So those would be rocks where there would be fractures and then water can get down in there. I'm going to pass around a picture of what's an ephemeral waterfall. So basically, especially in the slot canyons in monsoon season, we get a lot of flash floods in the area. So water kind of gets funneled into these places. And we have these waterfalls that then appear for a couple of hours and cause some erosion and then disappear, that are really pretty beautiful. Also, you know, not a place you want to be when there's a flash flood in a slot canyon. So, how many of you noticed when you were walking around or anywhere in the park today some of those big black boulders? Anyone notice any of those? Yeah, any ideas where those might be from?
Yeah, volcanic eruption.
Yeah, there was a volcanic eruption. Yeah, so I have a little lava rock that I'm passing around. It was a volcanic eruption, but it actually didn't occur here. It occurred, there were two kind of lava beds on Boulder Lakes and Thousand Lakes Mountain, so miles from here. And those happened about 20 million years ago. And then the rocks have since been transported down here from streams and waters. So we get lots of really rounded rocks, as you'll see, like the one I'm passing around. Almost imagine if you go down to a river and you pick up a rock, it's going to be a really smooth, rounded rock from being eroded by the river. So the same thing with these big black lava boulders. They've been transported down here and kind of deposited in weird spots. You'll look up on a cliff and see one kind of precarious up there. And they're rounded because of that movement through the water. So we kind of talked a little bit about, you know, the different layers that are here, the uplift in the monocline, the erosion, but geology is still kind of shaping life today and shaping how we can interact here with the park. One pretty fascinating thing, in my opinion, is that we have a really large number of rare and endangered plants here in the park. And that's not because we have a lot of poachers coming in and taking them or anything like that. It's just because this unique kind of tilted rock layer environment, a lot of these plants have adapted to only survive in this specific environment. So I'm passing around a brochure that gives you some information about those different plants that we have here, including a couple different types of flowers and pincushion cacti. So that's kind of an interesting thing, that these plants really can't grow anywhere else, and the reason they can grow here is just because of the geology. At one point, you know, the difference in from the bottom of the monocline to the top was about 2 miles. Today it's only about 2,000 feet, but still it's this very unique environment that we have here. So geology shapes how the plants can live here. We already talked about, you know, the water pockets are places for the animals to go get water, so they kind of shape how the animals can live here. And the geology also shapes how we interact with the park. The early people passing through this area couldn't easily get across the Waterpocket Fold. It was a huge barrier to travel. And that's where we get the second part of our name from, the capital Reef. The reef part is just, people would call anything that was a barrier to travel a reef, even if it was inland and not out in the ocean like a coral reef that we think of today. So the early settlers really couldn't get through everywhere. They could kind of congregate through this Fremont River gorge to create a larger channel. So that's why we have a lot of the settlements around this area for the Fremont people and the Mormon settlers, because this is the place they could pass through. And like I said in the beginning, the geology is the reason we're a park today. We became a national monument in 1937 to protect the geology here, that this is seen as a very unique place and something worthy of being preserved and talked about. And even today, geologists can look at the geology and learn a little bit about the past and maybe the environments that we used to have here. And from that, learn about what could happen in the future as the climate continues to change, what the environments might change to be as well. So I hope you guys enjoyed learning a little bit about the geology. I'm going to stick around for a few minutes, so if you have any more questions about any of this or anything in the park, feel free to come up and ask me. And thanks, and enjoy your day here. Not as far as the monocline.
Well, I meant the whole geological stuff here. Like, you know, we read articles and all that stuff. Is there any place in the world?
Not so much. The Colorado Plateau is a really unique place.
But in the other parts of the world?
Not any examples that I can think of.
No, okay.
Yeah, it's kind of just a combination of the plate movement, the different environments that applies the rock, the uplift, so it's really a combination.
So we were the plants there. I mean, they could be all different here.
Yeah, so those rare ones I was passing around, they aren't
Oh,
I mean, there are some
yeah.
that do carry over, but there are a lot that it adapted to just here at that region.
Okay, thank you.
This is my little bug. From erosion, so it's eroded over millions of years. So back to
I thought it was alive at first.
well, yeah, so there is differential erosion, so some rock layers erode more quickly than others. Like looking up at the castle formation, you can see those sharp fractures. That harder rock takes a lot longer to erode than this kind of soft sand inlet. So that does have to do with it, but also a lot of the erosion happens from rainwater that's coming down and filtering through cracks and maybe freezing and then thawing and expanding cracks. So it's not all just eroded away from water on the ground. Yeah, a lot of it can be water that's coming from rain. But yeah, again, it's over 50 million years. So, sometimes in geology, there's this tendency to kind of condense time, which I did, you know, in 15 minutes. But yeah.
You want to stand in line and wait after?
Yeah. So we believe, you know, a lot of it's just what we can look now and learn. In the 1840s, I think it's somewhere around. I'm not sure of the exact date, but yeah, the 1800s.
So
Do you have some good questions, Jensen?
the thing that was really fascinates me is that was like, did you say 250 grand? What was that area less than
Well, pretty. It's in every rock. It's just when it happens. So, you know, So I was talking about the green kind of, or the grayish chimney layer, that's reduced oxidized iron that's in there. So that one was formed about 225 million years ago. So when it was
Maybe a
formed,
spider
it was
then?
underwater. And so now it's exposed
No, I mean,
to air.
what ate the inside?
It's the iron is still in that reduced iron.
To quote Starship Troopers,
That can answer your
it's
question.
his brain.
And I think, as I recall, during that period of time, there was a life form that created put the oxygen into the water that started all the oxidization. The rest of the thing going on.
If it got oxidized, it was exposed to air when it was formed. So it wasn't underwater.
It wasn't underwater. Okay.
So over the course of millions of years, these rock layers were formed. There were periods of water and then there were periods of
Yeah. Fascinating. Thank you so much. Appreciate it.
Maybe this kind of question goes after that. Is there any kind of it is underwater? It's what's underwater?
I mean, yeah, the park was underwater at one
It's
time.
in salt water.
Salt water at one time. It's been under salt water and fresh water. So again, we're looking at 150 million years worth of rocks right here, and in different areas there were oceans here, drier periods. But the name reef is coming from just seeing that as a barrier. Because the early people didn't necessarily know the geologic history.
It's our name.
Yeah, it's our name for it.
But the second question is that there's one feature we saw here, the magnetic park. It's these little holes.
Oh yeah.
Is that created by just water or maybe salt?
Yeah. Those are kind of interesting because geologists don't really know. You might have noticed when you saw those that they would occur in just one little section and then there'd be a huge smooth wall. And so geologists don't really know why they occur, but they're from water. Most likely as water was going through the rock, it would hit maybe a rough patch. Instead of being able to keep permeating through the rock, it would come out the side. So you get those holes that are being eroded away from water coming out the side.
That is a very light color sand.
Yeah, a lot of it's in the Navajo sandstone. But we don't know why they would be this one strip as opposed to all over.
Well, we saw down on that scenic drive, there's this lower portion of a white rock with holes all over, and then you see this honeycomb. But then on top
like
it's
it
very solid rock.
Yeah.
You know, so it's different color. Well, it's not always on the top.
No, it's not always on the top, definitely. But unfortunately, yeah, we don't really know. It's from water. It's from water erosion. We don't know why it happens with the circle.
Are they still
They are, but erosion takes place over such a long period of time. It's hard for us to see. For the most part, we can't see that unless there's a huge flash flood and thing that carries a lot of rock with it. It's over time. Oh yeah, definitely. You can even the rock that is passing around. You can feel this is the sandstone that where they occur. You can feel how cheaply the sandstone erodes. Yeah, it's definitely so. That's great. Thank you very much. Hi. Can we sign it for you? You guys like this?
You're asking a question?
Why do they stay up and down?
See, they used to be flat, and why aren't they flat anymore?
Yeah, so it's like if you have all these rock layers right here, you have some motion underneath the earth, it rose up. Yeah, you can do it yourself. And so all the rock layers rose up there fall. You want to do it? You want to make all the rock layers rise up? Put them one side, behind the bush. Okay, they could rise up like that too. That's called an enhancement. So that happens too.
Good job. All right, what's your other question then? What is your favorite animal?
We don't have bears here. But my favorite animal is the bighorn sheep. You guys,
I guess I can try it.
you can try it. Well, you guys are from Colorado, right? You have bighorn sheep there too. We have the mountains. We have the
Why do people find rocks?
Is that gunner formation?
That's why I formed
How long is there one scorpion?
Yeah, look. It's a rock climber. You have to be careful around here though, because we have a lot of soft rock. That's not